Hello friends, welcome back to my channel, myself Chirag. In this video, I am going to discuss about AES Decryption Example, topic of network security. Let's check the outline of this video. First topic is AES Inverse Sub Bytes. Second topic is AES Inverse Shift Rows. Third topic is AES Inverse Mix Column. And the last topic is AES Inverse Add Round Key. In this video, all the transformation functions explained with example. Before start this video, subscribe my channel. Follow my blog chiragbhalodia.com. All the video materials are available on my blog. Let's start with the first topic, AES Inverse Sub Bytes, explained with example. Let's discuss AES Inverse Sub Bytes. For example, this is my ciphertext matrix. For example, I have to perform inverse sub bytes to the position S-01. Let's assume that the value of S-01 position is XY. Here all the values of this matrix is in hexadecimal format. So now, how can we perform AES inverse sub bytes on this particular value? Now look up this value in the inverse S-box table. For example, this is my inverse S-box table. Here X indicates the row and Y indicates the column in inverse S-box. Here X and Y intersect in inverse S-box table. That intersect value is replaced with the value of S-01 position. So it is called as inverse sub bytes. Next, this is AES inverse S-box table. Let's take one example and perform inverse sub bytes for better understanding. For example, this is my ciphertext matrix. I will perform inverse sub bytes on this matrix using the inverse S-box table. Let's find the first element of the matrix. Here, first element is 87. In this value, 8 indicates the row and 7 indicates the column. So here, 8 and 7 is intersect at the value EA. So it means value 87 is replaced with EA. Let's find the next element of the matrix. If you have any query, you can join my Telegram group Chirag Bhalodia. Link is given in description. Follow my blog chiragbhalodia.com. All the video materials are available on my blog. Next topic is AES Inverse Shift Rows, explained with example. Let's check the rules of inverse shift rows in AES. For example, this is my state array. I have to perform inverse shift rows on this state array. Rule number 1 is row 1, there is no shifting. So it means row 1 is as it is. The next rule is row 2, 1 byte circular right shift. So let's check here. Next rule is row number 3, perform 2 byte circular right shift. Let's check here. Next rule is row number 4, perform 3 byte circular right shift. So let's check here. So these are the rules of inverse shifting rows in AES. Now let's take one example and perform inverse shift rows on this state array. As per the rules, the first row is performed no shifting. So it means the first row is as it is. Next rule is row 2 performs 1 byte circular right shift. So let's start with the first value of the row 6E. It performs 1 byte circular right shift and moves to the second position of the row. Then next value is 4C. It again performs the circular right shift and moves to the third position of the row. Next value is 90. It performs the 1 byte circular right shift and moves to the last position of the row. And the last value is EC. It performs 1 byte circular right shift and moves to the first position of the row. Next rule is row 3 perform 2 byte circular right shift. Let's start with the first value 46. It performs 2 byte circular right shift and moves to the third position of the row. Next value is E7. It performs 2 byte circular right shift and moves to the last position of the row. Next value is 4A. It performs 2 byte circular right shift and moves to the first position of the row. And the last value is C3. It performs 2 byte circular right shift and it moves to the second position of the row. Next rule is row 4 performs 3 byte circular right shift. Let's start with the first value A6. It performs 3 byte circular right shift and it moves to the last position of the row. Next value is 8C. It performs 3 byte circular right shift and it moves to the first position of the row. Next value is D8. It performs 3 byte circular right shift and moves to the second position of the row. And the last value is 95. It performs 3 byte circular right shift and it moves to the third position of the row. This is all about AES Inverse Shift Rows. For further query, you can join my Telegram group Chirag Bhalodia. Link is given in description. Follow my blog chiragbhalodia.com. Next topic is AES Inverse Mix Column. Explain with example. In AES Inverse Mix Column, there is one predefined matrix. Inverse Mix Column is a transformation function of decryption process. So this predefined matrix is used for the decryption process. And this predefined matrix is used for encryption. So this second predefined matrix is used for the AES Mix Column transformation function. If you want to learn AES Mix Column in detail, then click on above I button. So here in this video, I am discuss about AES Inverse Mix Column transformation function. So predefined matrix for decryption is multiply with the state array and it generates a new state array. So here the question is that what is state array? State array is the output of previous transformation function in decryption process. And new state array is the output of AES Inverse Mix Column transformation function. Here all the values of both the matrix are in hexadecimal format. So this matrix multiplication is not same as the decimal value matrix multiplication. So here are the generalized equation for the matrix multiplication. Let's take one example to understand the AES Inverse Mix Column concept. For example, this is my state array. State array multiply with the predefined matrix and generate a new state array. Now find the first element of the new state array. To obtain the first element of the new state array, first row of the predefined matrix and the first column of the state array is multiply with each other and generate the first element of the new state array. As I told you, all the values are in hexadecimal format. So this matrix multiplication is not like a decimal multiplication. So here in this matrix multiplication, first of all find the multiplication value and then all the multiplication value is XOR with each other. But we all know that XOR operation is performed only on binary digits. So now find the first multiplication value. It is 0e into 47. So first of all, the value 0e is converted into the binary. It is 00001110. We all know that always hexadecimal value is represented in 8-bit of binary digit. But another issue is that we can't perform multiplication with binary value. So we have to convert this binary value into polynomial form using the Galois field 2 raised to 3 theorem. Here 2 raised to 3 means 8. So value 8 is also represented in 0 to 7. So here in this polynomial, the power of this polynomial is from 0 to 7. So this polynomial is called as Galois field 2 raised to 3 polynomial. Here in this polynomial, these 3 terms are indicated as 1 and the remaining terms are indicated as 0. So it means 0 indicate polynomial terms are ignored. So our polynomial for this binary value is x raised to 3 plus x square plus x. Now another value is 47. 47 is converted into the binary. It is 0100, 0111. These binary values are mapped with the polynomial form. So our polynomial is x raised to 6 plus x square plus x plus 1. Now both the values 0e and 47 are in polynomial form. So now we can easily multiply both the values with each other. Now multiply both the polynomial and eliminate same term from the resultant polynomial. Here same polynomial terms are x raised to 4, x cube and x square. Now in this resultant polynomial, the power of two terms are more than 7. So as per Galois field theorem, the power must be less than or equal to 7. So here both the power x raised to 8 and x raised to 9 are converted into less than or equal to 7. So for the x raised to 9, we can write x raised to 8 multiplied by x. Now both the terms have maximum power is x raised to 8. So here for x raised to 8, use irreducible polynomial theorem GF 2 raised to 3. So it replaces x raised to 8 with x raised to 4 plus x cube plus x plus 1. So now again eliminate the same term from this resultant polynomial. It is x raised to 3 and x. Simplify this polynomial and again eliminate the same terms. It is x raised to 5 and x raised to 4. And our final polynomial is x raised to 7 plus x square plus x plus 1. Now convert this polynomial into binary digits, because after all the multiplication we have to perform XOR. So now we have right to GF 2 raised to 3 polynomial. So here present terms of the resultant polynomial indicate is 1 and remaining as 0. So our binary value is 1,000,000, 0,111. Now find the next multiplication 0b into 37. For any query, you can ask me in Telegram group Chirag Bhalodia. Link is given in description. Follow my blog chiragbhalodia.com. All the video materials are available on my blog. Next topic is AES Inverse Add Round Key. Explain with example. In inverse add round key, 128 bits of state array is bitwise XORed with the 128 bit of round key and generate new state array. Here state array means output of the previous transformation function in decryption process. Inverse add round key function proceeds one column at a time. So it means column wise XOR operation will be performed. Now perform inverse add round key function with this state array and add round key. Let's find the first element of the new state array. To obtain the first element of the new state array, the first value of the state array EB is XOR with the first value of the add round key, which is AC. So it means EB XOR AC. It generates the first element of the new state array. Here both the values are in hexadecimal format. So we cannot perform XOR operation with hexadecimal values. So it means we have to convert both the hexadecimal values in binary format. Binary value of the EB is 11101011 and the binary value of AC is 10101100. Now perform XOR operation with this binary value and the resultant value is 01000111. Now convert this resultant binary value into hexadecimal format. It is 47. So our first element is 47. Now find the next element of the new state array. If you have any query, you can join my Telegram group Chirag Bhalodia. Link is given in description. Follow my blog chiragbhalodia.com. All the video materials are available on my blog. If you like this video, please hit the like button and share with others. Don't forget to subscribe my channel. Follow me on social media. All the links are given in description. Thank you for watching this video.